So I began my project by putting the project sales file into an RMD Markdown file, and then setting up all my libraries. So I used Pacman, TimeDate, DPLR, Magitor, T-Series, Stringer, Tidyverse, TDR, Lubridate, Magitor, Table, Feasts, Utils, ggplotter, DPLR, RVest, Data Table Reshape, FPP2, Core-Plot, Stats. Then I did an STR of project sales. So then I tried to clean the data by using some is.na on project sales to see how much missing data there was. So I found there was right bit of missing data, so I looked at the different variables. I looked at total variables, and then I got project sales total is NA project sales total, and then that equal to project sales unit price times SNA project sales total multiplied by project sales quantity, SNA project sales total plus project sales tax, SNA. Then I viewed it and I did the sum that SNA on it to see that all the missing data was gotten rid of. And when I got to the bottom, I found that it was 0. So then I went back and did the same for all the rest of the other variables. Total variables, unit price, quantities, cost of goods and services, and that got rid of all the missing data. Then once I was happy that that was all used, whenever that was all gotten rid of, I moved on to looking at trying to find patterns within the data. So I assigned identifiers to each of the variables: product line as factor, gender as factor, customer type as factor, city as factor, branch as factor, payment type as factor, unit price numeric as numeric, quantity as numeric, tax as numeric, sales total as numeric, date as date. Changed that a few times to get the time series to work. Time of sale as character numeric version. I have trouble with that. I don't know if that was right or not. I couldn't get it to work at the end. Cost of goods as numeric. Gross margin percentage as numeric. Gross income as numeric. Rating as numeric. And then I plotted a few of them. See down here. I looked at the 3 cities by sales total. Then I looked at the branches compared to the sales total. Then I did a pairs plot, and I looked at unit price, quantity, tax, cost of goods, and gross income. It's done better here. Price, quantity, cost of goods. And I was looking for different patterns, so I did a couple of graphs. I did weekly profit aggregate. So that was my pairs plot again. Then I looked at product line, electronic accessories by unit price, and I looked at all the product lines versus gross income by the city: sport and travel, home and lifestyle, health and beauty, food and beverage, fashion accessories, electronic accessories. Different colours are the different cities. Rwanda is pink, Naipaten is green, Yangon is blue. So you can see all the product lines are pretty similar. Now, health and beauty slightly different in Yangon to the other two, but the rest of them are generally the same. And I looked at food and beverages versus payment type, cash or card. Then I looked at product line versus cost of goods. Product line versus the total, and unit price versus gross income for all the different product lines. It's just more graphs. It's doing the same thing again, just trying to mess around with, see what I could find out from it. Then I went on to do the k-means clustering. I couldn't get the elbow method to work. I just used trial and error to find out the number of clusters per the best number of clusters to use. So I decided on 4 because tried 3 and it covered 87.5% of the data. Then I tried 4 and it covered 92.6%. And then I went on to try 5 and it covered 94.9%, but the data was getting unreadable, so I'm back to using 4, and it seemed to be the best option. Did a histogram of the unit price, quantity, sales total, cost of goods, gross income. Did a pairs plot. Pairs list. Then I did k-means. That's the first k-means with 3. And then 4. Then here's done better. That's with 5, but 4 looks better. That's 3. No, that's 4. 4 looked the best. It covered all the data points. So then I went on to do the correlation and looked at the core.test. There's 63% correlation between gross income and unit price. I did a few box plots, cost of goods, number of week, a few graphs. 63% correlation between gross income and unit price. 70% correlation between quantity of sales and total income. 70% correlation between quantity of sales and tax. 100% correlation between gross income and cost of goods. And a 64% correlation between cost of goods and unit price. Plotted a few of these. There's the figures. That's unit price versus product line. Gross income versus unit price. Sales quantity versus sales total. Tax versus quantity. And cost of goods versus gross income. Then I went on to start to do the time series. Now a new column to the sales data to show which week each sale was on. Then I divided the data into the volume sold each week and income produced each week by product. Then I tried to add the time of sale to each product and joined the two together, and I got weekly sales time for each product line. Got electronic accessories weekly sales. I joined the income with the volume and I got the weekly sales. Joined them and then I used that to get the time series. I fit a time series linear regression model on the unit price times electronic quantity, and I found that I needed to sell at least 9 units to make a profit. There's minimal lag in the ACF. Most of the points are in the curve. And then check the residuals. The sales are high in weeks 5, 10 and probably week 15, looking like a recurring pattern, starting low in week 1 to 4 and hitting lows in week 7 and 12. Residuals look okay, appears to be reducing lag in ACF, showing sales increasing across the season. Most of the residuals are within the curve. So I looked at a couple of different ARIMAs, residuals from linear regression model. Up in that one, and then I used the best one for the forecast, and it showed a forecast of 77 for week 15 from the electronic accessories volume versus time. So I went on to do that for food and beverages and plotted that as well. Plotted the one with the lowest ACF and BCF. It's 0.00 REMA for that one. And then I went on to do fashion time series, health and beauty, home and lifestyle, sports and travel, so my business decisions were week 5 was the best week for sales in electronic accessories, food and beverage and sports and travel. The worst for health and beauty. After each good week, there's sharp decline in sales. Starts the sales by introducing loyalty schemes, which repeat customers get 20% price reduction or exclusive offers to get them to come back in the quiet weeks. Number 2, advertise sales and special events with celebrity guests to generate interest and increase awareness of the products. To coincide with poor weeks for sports and travel, advertise on week 6 to be held in week 7 or 8. Even if not a success, the advertising should increase sales. Number 3, I would offer discounts for home and lifestyle products and health and beauty when buying electronic accessories or sports and travel products, and vice versa. When one product is having peak sales, the customer may be persuaded to buy a poorly performing product in the same area. Week 5, all products seem to slump. In week 6, 7 and 8, it introduced a family-friendly event to appeal to mothers with free childcare to drive up sales. Number 5, it reduced the price of food to entice customers, especially families. Offer 2 for 1 or family deals on meals to attract customers. IKEA does this. Makes a loss on the food to attract business. It is the cheapest place to eat in Dublin. If a customer come for a low-cost meal, they're likely to spend their money in a supermarket than elsewhere. If the supermarket can get the customer to make it a habit, they're more likely to spend the majority of the goods there, buy the majority of the goods there. I tried to do the time series for hour to see how the time of sale affects sales, but I couldn't get it to work. Sorry about using my mobile for this, but I couldn't get the YouTube clip to work, so I had to do it again on this. Apologize again for the poor quality. Sorry.